Hello DSci 2000. In this unit, we will be covering data manipulation in R. Here's the usual objective slide. Please pause and read before proceeding. So in this unit, what we're going to do is we're going to start introducing data manipulation in base R. We're eventually going to also cover data manipulation in dplyr, SQL, and although I won't be lecturing on this, I will also be giving you material on data.table as well. We're also going to cover data manipulation in Excel, Access, and Python. The one thing you should know is that R, dplyr, and SQL, as well as Python, work best for small to moderate data sets. Moderate meaning about a few million rows. Data.table works best for larger data sets. In Python, we're going to cover everything that I cover in base R as well as dplyr in a package called pandas, and we'll be discussing that when we cover the unit on Python. Needless to say, I will be throwing a lot at you in these next few units. To help guide you through these units, I would recommend you put your primary focus on base R, dplyr, and T-SQL. If you know how to execute these data manipulation tasks in those three paradigms, that will serve you very well professionally. And the way I will be teaching you T-SQL, data.table, Access, Excel, and Python will be primarily based on the syntax of dplyr. So as long as you know the base R and dplyr syntax and what it's doing, you should be able to follow these lectures pretty smoothly once you just see that it is, for the most part, very simple translation. I want to make sure that you are at least familiar with the base R and dplyr syntax. You might be asking, Yang, why are you teaching me all of these ways to execute data manipulation? The reason why is this. I have run into many situations where I have to ask an IT person for help on how to replicate a problem that I'm seeing in my dataset or that I'm seeing with my code. IT people are probably going to know SQL, but they're probably not going to be as familiar with R or Python. So anything you do in R or Python, you should be able to do in SQL as well. In addition to this, there is no perfect way to perform data manipulation in R. Three of these paradigms in R, base R, dplyr, and data.table, all have their advantages and disadvantages. Remember that base R and dplyr are meant for small to moderately sized datasets, whereas data.table is meant for very large datasets. I've worked with datasets that are so large that base R and dplyr aren't even a workable option. Such datasets, if you try to load them with base R or dplyr, will just simply crash. Pandas is the standard for data manipulation in Python, which I will be covering later. Professionally, I haven't found a good reason to switch everything from R to pandas, but I will be covering it later. So this slide is just talking a little bit about R Markdown. Let's talk about how to set up an R Markdown file. R Markdown files, as opposed to R files, are what we will be using for the remainder of the semester. R Markdown files have an extension of RMD, for R Markdown, as opposed to .r for simple R scripts. Let's go ahead and create an R Markdown file. Go to your DSci 2000 folder. Let's create a Unit 5 folder. Now that we've created our Unit 5 folder, let's go to the rproj file as usual. And let's go to the top left. I'm going to go to File, New File, but instead of R script, we're going to choose R Markdown. Then this will pop up. This is going to be our Unit 5 notes. So let's just call this DSci 2000 Unit 5. Set your name as the author. For the default output format, please stick with HTML and press OK. And this is what pops up. Everything after line 6 with these 3 dashes, please just get rid of it. And let's press Ctrl S to save this in our Unit 5 folder. Let's just call this intro to R with underscores. Save that. And we're going to do our usual git committing process. Right click on this folder, go to git bash here, cd to Unit 5, git add the intro to R file, git commit, and let's just give this a commit message. And we'll just minimize that for now. So this is an R Markdown file. I'll be guiding you in this lecture to create your first R Markdown file. This is the format that I want you to use for all homework assignments from here on out in this class. So let's start off by installing the dplyr and data.table packages. Go to the console on the bottom left. And let's just type install.packages, then create a vector with dplyr and data.table. So the packages are installed. The next thing you're going to want to do is, in your data files folder, you want to make sure that the simulated mnsalaries.csv file is in there, as well as the cities.csv file. These are available for downloading in D2L. So what we're going to do here is we're going to read in the simulated mnsalaries.csv file. Ignore this code for now. We have to modify it slightly for R Markdown. Let's go to our R Markdown file up here. And here is how you add code. First, make sure you have a blank line after the 3 dashes on line 6 here. Now we're going to add in some R code. Click the Insert button right here to insert a new code chunk, and click on R. What this does is it adds a new code chunk specifically indicating that you're throwing R code in there. Now we're going to read in the simulated MN salaries data frame. In the slides, we've called it simply DF. So let's call it DF in our R code. So we're going to assign to DF read.csv. Now here's where things are a little different compared to your regular .r files. For your .r files, the working directory is where your rproj file is located. That is not the case for an R Markdown file. For an R Markdown file, the working directory is where the R Markdown file is located. So we have to look at our folder structure. Here is where the R Markdown file is. And I need to tell R because with R Markdown files, the working directory is where the file itself is located, where the data files folder is. So I need to tell R, go back one folder to the DSci 2000 folder, go to the data_files folder, and then go to simulated mnsalaries.csv. Here's how I would indicate that in the read.csv command. Let's start a string. The first thing I want to do is I want to tell R to go back one folder. How you tell R to go back one folder is with this double dot construction. This will tell R to go back one folder. So now it's in the DSci 2000 folder, and then open up the data_files folder, and then in the data_files folder, go to simulated mnsalaries.csv. Code in an R Markdown file is executed just like it is in a .r file. I'm just going to put my cursor at the end of the line and press Ctrl Enter. And now let's go to the right. I can see that the data frame has been read in, and I can click the data frame as usual. So the biggest thing I want you to take away from this is that the working directory for an R Markdown file is different than that of a regular .r file. For a .r file, the working directory is where the R project file is located. For an R Markdown file, the working directory is where the R Markdown file is located. You need to be aware of this difference as you are testing your code. Let's go ahead and use the R Markdown format to demonstrate the examples that I'm going to show in this video. So the first data manipulation operation I want you to learn about is filtering. Filtering refers to taking a table of data and showing only a subset of rows that meet a certain condition. So what I'm going to do here is in the R Markdown file, I'm going to put a blank line after the R code chunk, and in line 12 right here, I'm going to add a # to indicate that I'm starting a new section. And I'm going to call this filtering. It is very important that you have at least one space between the # and the title. Otherwise, it will not show up as a section. Just so you can see what this R Markdown looks like right now, let's click the knit button right here. If your computer tells you that it wants to update packages, please just update those packages. But on my end, this is what the final output looks like. I can see that there's a title, my name, the date, as well as the code that I have right there. And I've started a new section called filtering. I'm going to close this. What's really nice about R Markdown in general is that you can integrate notes alongside your code. Here's what I mean by this. So for example, here, let's say I wanted to take note of the fact that R Markdown files have a working directory where the R Markdown file is located. I can simply do this. Make sure I have a blank line after the 3 dashes and before this R code chunk, and I can add in some notes. If I hit knit, I can see that my notes have been added. And what R Markdown allows me to do is it allows me to show the code alongside my notes. So please make sure you take advantage of this format. So let's talk about filtering. Remember that df $call refers to the vector whose column name is call in the data frame df. For example, df $sex refers to the sex column of df. Let's go ahead and demonstrate this in R Markdown. So right after the filtering section, I'm going to add in a blank line. And then in line 16 here, I'm going to insert an R code chunk. And I'm going to do df $sex. I'm going to add in some notes right above this R code chunk, just to say something like the sex column of the data frame df. Let's hit knit again, just to see the output. And here is that chunk of code that I added. Now I probably don't want to print that whole thing, so if I wanted to, I could also omit the output as well by setting eval equals false. I'll hit knit again. And now what it has done is it has that code right there, but it has not executed it directly in the R Markdown file. So recall that df $sex refers to the sex column of df. Let's consider the following problem. So let's say that I'm interested in only showing the rows of df for which the year is 2008. How do I go about doing this? What you do is the following. First, I'm going to add in some notes just to remind myself of what the code is doing. And I'm going to add in a blank line and add in some R code. What you do is as follows. First, you start off with the year column of df. You find all values for which it equals 2008. And you can see what that ends up doing right here. Using df $year equals 2008 gives a Boolean vector. It is true whenever the year is 2008 and false if it's not 2008. What's really nice about this is that wherever these values are true, on components 1 and 9, for example, are actually the corresponding rows of df with salaries equal to 2008. So what we can do then is we can use this Boolean vector as a row index in the df data frame. So here, for example, df $year equals 2008 gives me a Boolean vector consisting of true in the corresponding rows where the year is 2008. So if I throw that into a row index inside df, this will actually give me the corresponding values of df for which the year is 2008. Because I don't want to show this entire data frame, I'm just going to add head around this. And let's click knit. And here, what this does is it shows the first 6 rows of df for which the year is 2008. If you wanted to, you could remove head to see the entire thing, but I don't want to print out the entire output here. In general, when you use this construction, df with df $column with a condition on the column, and then a comma, what this does is it allows you to filter based on the column that you have specified. You can also use multiple conditions and columns in filtering if you wanted to. For example, here, we're filtering on rows for which the year is 2008 and the race is Hispanic or Latino. Let's go ahead and do this example right here. I'm going to copy and paste these lines. add a blank line right there. And we're showing all rows of DF with the year being 2008. And the race is Hispanic or Latino. And all we need to do is just add an and symbol with DF $sign race equals Hispanic or Latino. Let's hit knit again. If I scroll down, I can see that this command has given me the first 6 rows of the data frame for which the year is 2008 and the race is Hispanic or Latino. You can also add other logical expressions as well. Here is, for example, the rows of DF for which the year is not equal to 2008 or the sex is equal to F. Let's consider the following problem. Let's say I wanted all rows of DF for which sex is equal to F, year is equal to 2008, and race is equal to white. How you would think you could do this is as follows. Let's add an R code chunk. I'm just going to wrap head around this so it doesn't print everything. Let's type in DF where the year is 2008 and sex is equal to F and race is equal to white. Let's click knit. Now here's where things get interesting. If I look at the output, I have one row with the values I want, with the year of 2008, sex equal to F, and race equal to white, but a bunch of NAs. Why is this? Here's why. NA is neither true nor false. In R, if you execute NA equals true or NA equals false, you're going to get NA. Neither of those are true nor false. So, what is happening is as follows. When you are doing DF with a Boolean vector in the row index, what you are doing is you are filtering rows for which the condition is not false. The reason why those NAs are being kept is because NA is neither true nor false. When you execute this DF with the Boolean condition in the row index, it is showing true values in the Boolean as well as NA values in the Boolean. When you are doing DF with a Boolean row index, you are showing rows for which the condition is not false, which includes trues and NAs. This might not necessarily be what we want. In this case, for example, we want only the true values. We don't want the NAs. So how do you deal with that? What you do is you wrap which around the Boolean conditions, which, when you execute it around some logical statements, will only return the row indices for which the condition is true. So for example, in this situation, so I'm going to copy and paste these lines of code into line 40 right here. Make sure you have blank lines surrounding these. This one keeps the NAs, but if you don't want to keep the NAs, you have to wrap which around this logical condition. Now let's go to knit, and now you can see that when we didn't include which, the NAs were being kept. When we did include which, the NAs were dropped. So this construction right here shows all rows for which this condition is not false. Not false includes NAs as well as true. When you wrap which around a logical condition, it only shows rows for which the condition is true. Generally speaking, whenever I'm using base R, I use which in all filtering. It is very rare where I intentionally want to keep the NAs. Another way you could avoid NAs is by manually specifying that for each column, you're going to add not NA for each one of them. Obviously, as you start working with more columns, this ends up not being that doable, but this is a possible option if you only have a few columns with NAs in them. Let's go ahead and do this. So equivalently, instead of wrapping which around here, we could do, let's just get rid of which, and is not is NA, df year, and not is NA, df sex, and not is NA, df race. My code's getting pretty long, so I'm just going to press enter after this and sign. And let's press knit. And here we can see that these two outputs are identical. So my only point here is that if you wanted to, you could manually specify that you don't want NAs in your columns by using this not is NA construction on the column. So to summarize, there are 3 ways to filter that you have been taught in this video. The first way is df with just the Boolean vector as a condition in the row index. This generates all rows of df where the condition is not false. So this could include NAs. The second way you can filter is using that same condition and manually specifying not is NA for each one of those columns. The third way you can filter is simply by adding which around the column condition. Which generates all rows of df for which the condition is true. As a general rule, I like sticking with which for its simplicity. So let's go back to our last filtering example. And as I mentioned, it can be quite tedious to have to specify not is NA for every single column. Is that really necessary? Because there could be some columns that just don't have NAs at all, and it's unnecessary to put those logical statements in. Is there a way to find out what columns have NAs in them and what columns don't? Here's how you do that. Let's go ahead and add our code chunk. And in this filtering example, I'm only looking at the year, sex, and race column. What I can do is I can use unique around each one of those columns. Let's go ahead and knit this. What's very nice about unique is that unique is a function where if you give it a vector, it will show you the unique values of that vector. We can see then that year has no NAs, sex does have an NA, and race has no NAs. So thus, we only need to specify not is NA on the sex column only. Let's go ahead and make that change. Let's add our code. Let's copy and paste this. And all we need is that on the sex column. Well, let's go ahead and knit. And we can see here that our results are identical to what we saw earlier. So we only need to specify not is NA on the sex column based on our investigation with what we saw in unique. So as we saw here, only the sex column has NAs. Thus, we only need to specify not is NA on the sex column and not the other two. Another thing you could do, instead of unique, if you want raw counts, is by using the table function. What the table function will do is it will not only show you distinct values that are in that vector, but it will also give you counts as well. For example, in this situation, so let's say I want a count of distinct values in the sex column. Let's add in our code chunk. And I'm going to do table df $sex exclude equals null. Let's knit that. So what this is telling me is I have F, M, and NA in the sex column, and these are the number of times that they all appear. So the table function is another way I can see what are the distinct values in a particular vector, but it also provides me the counts. I find that table is very useful when you are unfamiliar with the dataset and you just want to see what's in it. Just to summarize what I've discussed so far, we've discussed the 3 ways of filtering and the fact that I prefer using which when filtering. And you can also use the unique and table functions on a vector to get the unique values and counts of every unique value in a column of a data frame. Let's go ahead and commit this file. First of all, make sure that your file is saved. What's very nice about R Markdown is that it saves automatically each time after you knit. So you might not have to save it, but if this is red, make sure that you run the knit button one more time just to make sure this is saved. And now let's add the R Markdown file as well as the HTML file to Git. Go to Git Bash. And recall we are currently in our Unit 5 folder. You have to make sure that you're in your Unit 5 folder at this point. If you're not, make sure you CD to it. The next thing I'm going to do is I'm going to add the HTML file to our Git repository. I'm going to type in git add intro to r.html. Then I'm going to do a commit. And I will just say that we finished filtering notes. Let's do a git push. And this is how you will be submitting your future assignments with R Markdown code as well as HTML outputs. And that's all I have for you in this video.